Alright, so we need to make an equation for this reaction. So our reactants will be isopropanol, so C3H7OH, and that is all liquid, so L. That reacts with air, so that'll be O2, and that's as a gas. And then that creates carbon monoxide, which is CO, and again, that's gas, and water vapor, which is gaseous, H2O. So now that we have our reactants and products set up, we need to balance it. So first, let's start with carbon. 3 carbons here, 3 carbons here. So we need a 3 to make sure there's 3 on both sides. Now let's do hydrogen. There is 8 hydrogen here, and only 2 here, so we need a 4. Now there's 8 on both sides. And then oxygen. There's 3 here, and then there is 7 oxygen on this side. So if we put a 3 here, there's 7 on this side and 7 on both sides. So now we have a balanced equation.
Okay, so now what we are going to do is we are going to figure out the mass of oxygen needed to react with 290 milliliters of CO gas. So the first thing I'm going to do is write 290 milliliters of CO. I'm going to put that over 1. And now what I'm going to do is I'm going to convert that into liters. So I'm going to put 1 liter over 1,000 milliliters. Okay, and that's going to, the milliliters here and milliliters here are going to cancel, so I'm going to be left with milliliters. And now what I'm going to do is I'm going to convert this into moles. So I'm going to put 1 mole of CO is equal to 22.4 liters. So now the liters are going to cancel, and I'm going to be left with moles. So now I need to get this from moles of CO to moles of oxygen. So I'm going to have 3 moles of O2 is equal to 3 moles of CO. Okay, so now the CO and CO cancel, so I am left with moles of oxygen. Okay, now I'm running out of room, so I'm going to come down here, and I'm going to convert 32 grams of oxygen, but now I'm going to convert the moles of oxygen into grams of oxygen. So 32 grams of oxygen is equal to 1 mole of oxygen. Okay? And now when I've solved this out, I'm going to get this whole thing is equal to 0.41 grams of oxygen.
Okay, so now we're going to move on to number 3, which is if we have 10 grams of both of our reactants, what is the mass of the amount of H2O that will be produced? So we need to figure out which is our limiting reactant and which is our excess reactant. So what we're going to do is we're going to take 10 grams of each reactant and convert that into grams of H2O and find the smaller number, and that will be the maximum amount of H2O that can be produced. So we're going to start with 10 grams of O2 over 1. And we want to reach H2O. So first we need to turn this into moles. So the molar mass of O2 is 32 grams of O2 for 1 mole of O2. And then if you look at our equation, there's 3 moles of O2 for 4 moles of H2O. So 3 moles of O2 for 4 moles of H2O. And then we need to convert this into grams. So 1 mole of H2O And H2O has a molar mass of 18.02 grams per mole. So all that comes out to be 7.508 grams of H2O. But then we need to take into account sig figs, so that's actually 7.51 H2O. And I apologize, this is supposed to be 10.0. Now we're gonna move on to finding out how much water we can produce from 10 grams of isopropanol. So 10.0 grams of C3H7OH. So there are 60.11 grams of C3H7OH per 1 mole. H7OH. Then, as you can see here, 1 mole of C3OH is equal to 4 moles of H2O. And then convert this into grams. H2O is 18.02 grams H2O. And this comes out to be about, well, let's put it in our calculator. So, times 1 times 4 is 11.99 grams of H2O. So, since the O2 is the smaller number, that is the maximum amount we can get, and this will be our X, and this isopropanol will be our XS reactant. Okay, so now we're moving on to the second part of number 3, which is finding the mass of our excess reactant. So we know that we have 10 grams of O2 since that is our limiting reactant. And to find the mass of the excess reactant, we need to find the theoretical mass of our isopropanol and take the actual and subtract that by the theoretical. So we're going to start with 10.0 grams of O2 over 1, and we will go and take this and convert it to isopropanol. So first we need to convert this to moles. So again, 32.00 grams of O2 per 1 mole. Then if we look at our ratios up here, there are 3 moles of O2 per 1 mole of C3H7OH. Then convert this into grams, and 1 mole of C3H7OH is 60.11 grams of C3H7OH. I'm going to double check that. Yep. And then once you multiply this all out and all your units cross out, you should get 6.26 grams of C3H7OH. So this would be our theoretical amount that we need if we have 10 grams of O2. And then we have 10 grams of C3H7OH. So we need to subtract this from our actual amount. 6 grams. And this comes out to be 3.7 grams of C3C7OH with sig figs. See there.
2.50
So we're going to be moving on to number 4,
grams.
which is if we have 2.5 grams of isopropanol and we have enough carbon monoxide, we have enough O2, how much carbon monoxide will be produced, assuming an 83.2% yield? Okay, so he took the 2.5 grams of isopropanol and he's converting it into moles. And now he's using the ratios in the equation to convert that into CO.
So good.
So the molar mass of CO is 28.01. So he's converting it to grams here. And that all comes out to 3.49. 3.49 grams. However, this is the theoretical, and the actual yield is only 83.2% of that. So we need to multiply our actual by 0.832 to get our actual yield, which is 2.91 grams of CO. So now we're moving on to our hydrate problem, which asks if we have this hydrate and it has a molar mass of 315.5 grams per mole, what is the value of the x variable, and then what is the name of the hydrate? So to figure this out, we're going to first find the molar mass of the non-hydrate part, I guess you could call it. So that would be barium hydroxide. So then barium has a molar mass of 137.33. And then that's added on to the molar mass of oxygen, which is 16. And then hydrogen, which is 1.01. So when you add that all together, you get
Jacob, you copied this down wrong. Wah.
Now we can figure out the molar mass of the beryllium hydroxide. So it'll be 137.33 plus 2 times 16 plus 2 times 1.01. So same thing as what Jacob wrote. So we subtract that mass from the total molar mass. So it'll be 315.5 grams per mole minus 171.34 grams per mole, and that will equal 144.16. Now we want to divide that by the molar mass of water, which is 18.02, to figure out the value of x. And that comes out to 8. So now we know that x equals 8, and now that we know that, we can name the hydrate. So we know the first part is barium hydroxide, and we know that there are 8 water molecules, or there's 8 H2O molecules. So we know that the name is barium hydroxide, and then we add our prefix onto the hydrate, and since there are 8, it will be octahydrate.
I hope you realize that whenever there's a slight audio error, I'm just going to not say the entire thing again, but just replace like a few. It's okay. It will be fixed.
Just when
There you go.
once we get to the point, I start writing the name. Just
You sure this has sound, right?
Yeah, probably.
I mean,
It has sound. I don't know if we're gonna be able to hear it perfectly. I can just turn it up.
wait, is that down all the way?
Do we record all of them with that? I really hope so.
Wait, first stop.
we record.